So we came to the conclusion that the adjacent side is cos beta, for which I'm just going to simplify down to cos b, mainly because I've not got easy access to this letter unless I move back to LaTeX, which I could do, but I judge I would have to keep doing. I'll have to keep doing print screens, transfers across, and so on. So for now, let's just be aware that this is cos beta. This length here is cos beta, and we came to that decision by just saying, well, cos beta is a over h. The a is just this red line here, the adjacent of that right angle triangle. The hypotenuse is of length 1, hence a divided by 1 is just a, so that adjacent length is cos b as I've labeled it here. And to be more specific, we can say, instead of calling it a, we can call it AE, capital AE, because that's what the length represents. The adjacent side, again, just to keep repeating, repetition, repetition, repetition. There is AE, and that is the same as cos beta. I'm going to put it on this diagram here as well to remind us, because we're going to need that information later. Again, I'm just going to call it cos b is that length from AE. Now, one other thing to consider, let's consider sine alpha, although there's not one other thing to consider in this video will be sine alpha. So for alpha, let's make this very clear. I'm looking at this right angle triangle here. That's what I'm doing for alpha. So I'm looking at this right angle triangle that goes from AF, EF, and finally AE. AE, of course, we know is cos B. That's in there already. We've calculated that. But sine alpha is the opposite divided by hypotenuse. We do not specifically care for the adjacent, or not, that is to say, at this point in time, we judge that the opposite and the hypotenuse are fundamental to the discussion on what sine, in terms of sine alpha. Sine alpha, therefore, is the opposite divided by hypotenuse. The hypotenuse is AE, so I can get rid of the hypotenuse symbol and make it much more specific and say I know that the hypotenuse is that length AE. I can also be more specific by saying, instead of calling this opposite, let's call this EF, and there you see I do that there, EF over AE. We finally can say, however, as a result of what we have just discussed in the past, that AE is cos beta, so why not make that transfer, that substitution of information, that substitution as well, to suggest that I'm now going to call AE cos beta. And so what we can then do is we can multiply both sides. I can multiply the right hand side by cos beta there, and I can multiply the left hand side by cos beta here, and this will cancel to make 1, leaving just EF as I've got here. And then I'd have cos beta times sine alpha, or the equivalent of sine alpha cos beta, if you wanted to put the alpha and beta in a way that is alphabetical, or whatever way you wish to put it. We now have a new rule, which is that sine alpha times cos beta is EF. And I can label this in here so that we can see specifically what I'm talking about when it's actually on the diagram. I'm suggesting to you that by the laws of trigonometry, we've done nothing more complicated than consider what sine and cosine mean for these two separate triangles, and in these circumstances, for that bottom triangle, that EF now can be said to be sine alpha cos beta, as I've described there. So now we have two labels for our triangle. We have the hypotenuse of the bottom and the adjacent of the top, which is cos b, and we have the opposite of the bottom, which is sine alpha cos beta, and that will aid us in our further conversation about double angle formula next. Not to forget, just to make sure we're aware of how we're going to apply this information, we're looking to simplify this 2 sine 15 degrees cos 15 degrees utilizing double angle formula once we have a full conversation about it to perhaps aid understanding.